Alright, let's solve today's Leetcode question. So today's Leetcode question is maximum number of operation to move ones to the end. So we are given a binary string. That means that only the inputs we are receiving the string will only involve the numbers like zeros and one, and we can perform the following operation in the string any number of time. So we have to choose an index, any index from the string, as long as the index is less than the total number of the array count, and then such that index of the item is equal to 1 and index plus 1 is equal to 0. That means let's make some diagram in here. 1 0 0 1. Why is it so small? All right, so let's consider like we have choose the index. So our index can be the, let's consider we have index in here. Why is the arrow so small? Never mind. And then our index plus 1 is supposed to be 0. And then we can move the character from index of I to the right until it reach to the string or another 1. So that means we can swap. Okay, let's make it like this. 0 1, then we got 2 0 in here. So mean like we can swap this one to this like this, and then it will begin like this. It is not like swapping like this. It is if I have to answer like one by one. I mean that we swap this index 1 and index 0. After that we swap the index 1 and index 2 like this. So that is the operation we can do if we choose the I is 1. So we have to return the maximum number of operations that we can perform. So let's run through the example 1, which is a 1 0 0 and 1. And the next is also 1 and 0 and 1. Right. So we got this integer string, which is a binary string. And then what I'm going to do is I'm going to calculate the number of ones. Let's call a variable called ones. So I just want to monitor how many is one that we have in the 4 iterated, and then next is the answer. So let's go like the index start from the 0. So we got the 1. So the 1 began 1. And then next, if our elements began the 0, what we want to do is we want to check the element 0 and the element next to the index is 1 or not. That means we are finding the case like this in here. In case if there's a 1, that is the case we find it, but this is the case not a 1 at yet. So what are we going to do is we only need to do condition here. Maybe we can check with like all condition. So if it is a less ident, we're going to addition of the answer with all the ones. Let's go, we have answer in here, which is initially 0. Or if we are in that index 2, so we can addition of the answer in answer plus 1. So answer is 0, so that would be answer is 1. And then we go through next ident, which is also 1. Then we plus 1 to the 1, 1 became 2. The same for the 1, 1 became 3. Next is 0. So if ident became 0, then right next to the ident is also 1. What do? We add our ones and answer, which will begin the 4. And then if it begin 1, there's nothing much ident. So since it is less index, so we're gonna add it. So which will make us the 4 in total. So let's run through it. Let's go like 1 since we want to calculate the answer of 1, and let's go answer variable for us to return the answer in here. And then we will have a, okay, I can make a array with our input string so that we can easily index each character in the string of binary. And the next is what I need is a count of string. So I will call that s.count. So it's just quite simple. We just do the for in loop from 0 to the last index of our binary string, and then we're gonna check like if string of the index is equal to 1, that means we just increment our 1. If not, that means our case is 0. So that is where our actual intention came in. If I is n minus 1, that means we are in the last index of, we're gonna check like our index plus 1 is 1. That means the case like last item or something like this, 0 and 1. We gonna add answer with the 1, and then we can just return it. So if I have to dry run through it, let's consider we have a binary string which is let's go 1 0 0 1 1 0 1. So let's go through it. So we are in here. Let's consider like this, and then we go through like 1 by 1. Since the first item is 0, so we check like 1, so we increment the 1. So 1 become 1, and the next item we are going to bump it into here, so which become the 0. And then in that case we're going to check like if the index is the last item, no, and then we're gonna check if our index plus 1 is also 1, no, so we don't do anything and move on to the next iteration. So if in the next iteration we also state the check, so we are going to check like our string of the index is 1, no, then we come into the else case. So the case is 0, we're going to check the last item, no, but the index right next to the index is a 1. So in that case we're going to addition of the answer into answer plus 1, which will make us the answer become the 1. And then there is actual 1 is coming, so we're going to move the 1 to here. So and then we check 1, the plus 1 to the 1, 1 became 2. Next we're going to check 1, 1 became 3. Next is a 0. So in the 0 case I'm going to check again. So since that right next to the item of the index of 1 2 3 4 5 is 1, so that means like we are in index 5, and then our index 5 plus 1, which is index 6, is also the index 1. What do? We add our answer plus 1, so which will make us the answer in 4, and then we switch to the last iteration. So we're gonna check okay, index is n minus 1. Since the I, yeah, that's the last iteration, and then we also check I plus 1 since there's no I plus 1, so we don't need to check it out. Yeah, I think that's pretty much open. Let's try to run through it. Oh wait, I make a huge mistake in here. So it's the left item, we just increment the 1 into here. 4, that's done. What did I do wrong? Okay, this is a count, not n. I can make a lot of mistakes. Silly me. I should be called like count and try to run again. I think the time complexity for this solution is O of n squared, since we have a nested in here. I think it's just O of n. The same for the space complexity, since we only had used the one extra variable, which is converted our binary strings into the character array. Yeah. So both space complexity and time complexity quite O of n. Yes, that's pretty much of it, and see you in the next video. Bye.